Paralleling the neutral conductors allows the current to return to the service entrance as a single path. This can reduce voltage imbalances and ensure proper grounding. According to the National Electrical Code, or NEC, a grounding electrode conductor, or GEC, must be connected to every panel in the electrical system. It is appropriate for each panel to have its own GEC. A high neutral current, such as 2.5 amps, and a corresponding magnetic field, such as 4.6 mg, are concerning. This indicates a possible fault in the electrical system, such as an open neutral or improper bonding. Here are a few recommendations. Firstly, contact a qualified electrician to locate and repair the fault causing the excessive neutral current. Secondly, install a magnetic field meter to monitor the magnetic field exposure over time. If the field remains elevated above 4 mg, consider mitigating measures such as shielding or rearranging furniture. Thirdly, ensure that all electrical panels and equipment are properly grounded and bonded in accordance with the NEC. Fourthly, consider upgrading the electrical system to increase the ampacity of the neutral conductors and reduce the magnetic field exposure. Electrical systems rely on properly grounded and bonded components to ensure safety and efficient operation. The neutral conductor plays a critical role in carrying unbalanced currents back to the source. When multiple panels are installed, the neutral conductors are often parallel to provide a lower impedance path for the current. This paralleling helps to minimize voltage drops and maintain stable voltage levels throughout the system. The grounding electrode conductor, or GEC, is another essential component of the electrical system. It provides a direct connection to earth, which helps to protect against electrical shock and equipment damage. The NEC requires that a GEC be connected to every panel in the electrical system to ensure that all panels are properly grounded. The presence of high neutral current and associated magnetic fields can indicate a potential problem with the electrical system. Excessive neutral current can be caused by a variety of factors, including unbalanced loads, open neutrals, and improper bonding. When the neutral current is high, it can create a magnetic field that can be harmful to human health. To address the issue of high neutral current and magnetic fields, several steps can be taken. Firstly, it is important to identify and correct any faults in the electrical system that may be causing the excessive current. This may involve inspecting the wiring, checking the connections, and testing the grounding system. Secondly, it is important to ensure that all electrical panels and equipment are properly grounded and bonded in accordance with the NEC. This will help to minimize the risk of electrical shock and equipment damage. Thirdly, it may be necessary to upgrade the electrical system to increase the ampacity of the neutral conductors and reduce the magnetic field exposure. This may involve replacing the existing neutral conductors with larger conductors or installing a new grounding system. Furthermore, monitoring the magnetic field exposure over time can help to determine the effectiveness of any mitigation measures that are taken. If the magnetic field remains elevated above 4 mg, additional measures may be necessary, such as shielding or rearranging furniture. Shielding involves installing a barrier between the source of the magnetic field and the area that is being protected. This barrier can be made of a variety of materials such as metal or specialized shielding fabric. Rearranging furniture can also help to reduce the magnetic field exposure. By moving furniture away from the source of the magnetic field, the distance between the person and the field can be increased, which will reduce the exposure. In addition to these steps, it is also important to educate occupants about the potential hazards of high neutral current and magnetic fields. This education should include information about the causes of high neutral current, the health effects of magnetic fields, and the steps that can be taken to reduce exposure. Ultimately, addressing the issue of high neutral current and magnetic fields requires a comprehensive approach that involves identifying and correcting faults in the electrical system, ensuring proper grounding and bonding, upgrading the electrical system if necessary, monitoring the magnetic field exposure, and educating occupants about the potential hazards. By taking these steps, it is possible to create a safe and healthy environment for everyone. Electrical panels are the central distribution points for electricity in a building. They receive power from the utility company and distribute it to various circuits throughout the building. Each circuit is protected by a circuit breaker, which is designed to trip and interrupt the flow of electricity in the event of an overload or short circuit. The neutral conductor is an essential part of the electrical system. It provides a return path for the current to flow back to the source. In a balanced system, the current flowing through the neutral conductor is minimal. However, in an unbalanced system, the current flowing through the neutral conductor can be significant. Unbalanced loads occur when the amount of electricity being used on each leg of the electrical system is not equal. This can happen when appliances or equipment are connected to different legs of the system and are not used equally. Open neutrals occur when the neutral conductor is broken or disconnected. This can cause the voltage on different circuits to become unstable, which can damage appliances and equipment. Improper bonding occurs when the grounding system is not properly connected. This can create a potential shock hazard and can also damage appliances and equipment. Magnetic fields are created by the flow of electricity. The strength of the magnetic field is proportional to the amount of current flowing through the conductor. High magnetic fields can be harmful to human health. Studies have shown that exposure to high magnetic fields can increase the risk of certain types of cancer, such as leukemia. The NEC sets standards for the safe installation and operation of electrical systems. These standards are designed to protect people and property from electrical hazards. It is important to ensure that all electrical work is performed by a qualified electrician and that all electrical systems are installed and maintained in accordance with the NEC. Upgrading an electrical system involves replacing existing components with new components that are designed to handle a higher load. This can involve replacing the service entrance cable, the electrical panel, and the circuit breakers. Upgrading the electrical system can improve the safety and reliability of the electrical system. Magnetic field meters are used to measure the strength of magnetic fields. These meters can be used to identify areas where magnetic fields are high. Shielding involves installing a barrier between the source of the magnetic field and the area that is being protected. This barrier can be made of a variety of materials, such as metal or specialized shielding fabric. Rearranging furniture can also help to reduce the magnetic field exposure. By moving furniture away from the source of the magnetic field, the distance between the person and the field can be increased, which will reduce the exposure. Educating occupants about the potential hazards of high neutral current and magnetic fields is an important part of creating a safe and healthy environment. This education should include information about the causes of high neutral current, the health effects of magnetic fields, and the steps that can be taken to reduce exposure. In conclusion, addressing the issue of high neutral current and magnetic fields requires a comprehensive approach that involves identifying and correcting faults in the electrical system, ensuring proper grounding and bonding, upgrading the electrical system if necessary, monitoring the magnetic field exposure, and educating occupants about the potential hazards. By taking these steps, it is possible to create a safe and healthy environment for everyone. When dealing with electrical systems, always prioritize safety and consult with qualified professionals. The information provided here is for general knowledge and informational purposes only, and does not constitute professional advice. Always consult with a qualified electrician or other professional for any questions you may have regarding your electrical system. Improper handling of electrical systems can be dangerous and can lead to serious injury or death. Therefore, it is essential to take all necessary precautions and to follow all applicable safety codes and regulations. Electrical safety is paramount. When working with electricity, there are several key safety measures to follow. Always to energize the circuit before working on it. Use properly insulated tools. Wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical systems while standing in water or on a wet surface. Be aware of your surroundings and avoid contact with any exposed electrical wires or components. If you are not comfortable working with electricity, or if you are unsure about any aspect of the electrical system, always consult with a qualified electrician. Electrical systems can be complex and dangerous, and it is important to have the knowledge and skills necessary to work on them safely. By following these safety measures, you can help to prevent electrical shocks, fires, and other accidents. Remember, safety should always be your top priority when working with electricity. The NEC is a comprehensive set of standards for the safe installation and operation of electrical systems. The NEC is updated every 3 years to reflect the latest advances in electrical technology and safety practices. It is important for electricians and other electrical professionals to stay up to date on the latest changes to the NEC. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. The NEC also includes specific requirements for different types of occupancies such as residential, commercial, and industrial buildings. Compliance with the NEC is essential for ensuring the safety of electrical systems. Many jurisdictions have adopted the NEC into law, which means that compliance with the NEC is legally required. Even in jurisdictions where the NEC is not legally required, it is still considered a best practice to follow the NEC. The NEC is a valuable resource for anyone who works with electrical systems. It provides clear and concise guidance on how to install and operate electrical systems safely. By following the NEC, you can help to prevent electrical shocks, fires, and other accidents. The NEC is available for purchase from the National Fire Protection Association, or NFPA. The NFPA also offers a variety of training and educational resources on the NEC. In addition to the NEC, there are other resources available to help you learn about electrical safety. These resources include books, articles, websites, and training courses. By taking the time to learn about electrical safety, you can help to protect yourself and others from electrical hazards. Remember, electrical safety is everyone's responsibility. By following safe practices and staying informed about electrical hazards, you can help to create a safer environment for yourself and others.